What's up, guys? This is Jahangir from MedPorium, and today we're going to be diving into the start of our organic chemistry topics in the MCAT. So today we're going to be going over just some basic naming so that when you do naming for like IUPAC nomenclature, you know what each of these functional groups end with, start with, and so forth. Now, if you guys haven't seen the video I made over IUPAC nomenclature, definitely check that out, because if this is your first time in organic chemistry, your first experience in organic chemistry, definitely watch that video before watching this one, especially since this series is mostly dedicated to the MCAT. But you can use this whole entire series, all these videos, if you're studying or self-studying organic chemistry. Maybe it's the summer and you want to get a head start, or you're in your organic chemistry class right now and you just need some supplemental material. You can use it for whatever. So today we're going to be talking about just basic naming, just things that we have to know for IUPAC nomenclature, like carbons, alcohols, what they end with, geminal, vicinal, diols, so forth. So first off, let's start with carbons. So I'm going to do a little bit of a graph over here. So number of carbons and the name. Now, if you've taken organic chemistry before, there should be a decent review for you, because if we have one carbon, then we're going to have a meth, methane, methyl. So one carbon means meth, so I'll just do meth. And if we have two carbons, we're going to have an eth. 3 will be a prop. 4 bute, and so forth. So 5 would be pent, 6 would be hex, 7 would be hepta, 8 would be octa, 9 would be nona. So this is very important to know, because if we're naming our compounds, let's say we have a alkane. So an alkane is just going to be single bonded carbons or single bonded hydrogens. So when we add an ane to it, if we have a carbon like this, a carbon that's bonded to 4 different hydrogens, we are going to have a methane. So alkanes, they have the suffix ane, so it would be meth plus ane, and this molecule over here would be a methane. Same for ethane, which ethane would be, if we're doing our using our IUPAC naming, if you wanted to, we could do CH3 bonded to CH3. This would be an ethane. And propane, if we want to do the sort of, I guess you could say, lines, this is what a propane would look like. Remember, each of these endpoints and hills and valleys represent a carbon. So there's a carbon right here, carbon right here, carbon right here. And since there's nothing else bonded to it, we assume that it's bonded to hydrogen. So this carbon is bonded to 3 hydrogens, so this would be CH3. This one's bonded to 2 hydrogens, and this is a CH3 as well. Now, that's just basic naming for any of our alkanes, where we look at the number of carbons and see which one it connects to. So one carbon, we're going to have in its alkane, methane. 2 ethane, 3 propane, 4 butane, 5 pentane, and so forth. So now let's talk about our halogens. So this is basically, if you remember from general chemistry, our halogens are going to be, I think it's group 7. It's to the left of the noble gases, and they're going to have a valence of 7, so they can take one more electron. That's all they need to fill their octet. So halogens. Now, our halogens are going to include, fluorine, chlorine, bromine, iodine. And when we're using IUPAC naming, if we have a fluorine, for example, we will use fluoro, chlorine, chloro, bromine, bromo, iodine, iodo. So that is a name that you want to memorize for these halogens, just like fluoro, chloro, bromo, iodo. Pretty basic. But that's just very important to know when you're using IUPAC naming. Now, what about if we have double bonds around our carbon, or if we have triple bonds? So if we have double bonds, this is going to be referred to as an alkene. alkene. So alkene means that we have some sort of double bond. I'll just do DB. And if we have triple bonds between these carbons, so actually let me just switch it to this carbon. If we have triple bonds between our carbons, so something like this is going to be an alkyne. And alkyne is going to end with -ine. Alkene over here is going to end with -ene. So if we have a double bond and the number of carbons we have is 2, this would be ethene. If we have a triple bond and the number of carbons we have is 3, we would use a propyne. So that is the basic naming for all of these carbons, and we're talking about our halogens. And now let's talk about diols. So if you didn't know already, and let me switch my color here, alcohols will usually have the suffix ol, or the suffix ol, and the prefix hydroxy. So if we have an alcohol and we have 2 alcohols, we can have a diol. So diols are 2 OHs, 2 OH groups, or 2 alcohols. Now, there are 2 different types of diols that we have to know. So let me change my color here. We have a geminal diol. And geminal diols are going to be on the same carbon. So if let's just say we have a 1, 2, 3, 4. We have butane right here, and we have an OH right here, OH right here. This is a geminal diol. Geminal diol, because they are both on the same carbon. Now, the other one that we have is known as our vicinal diol. So vicinal diol is the opposite. So we're going to have those 2 diols on adjacent carbons. So this is what a vicinal diol would look like. Now in the MCAT, there are some common alcohols that we just have to know the name of. Now one of them is ethanol. Ethanol, and as you can tell, ethanol, we're going to have 2 carbons and we're going to have a alcohol. And another name for this is ethyl alcohol. And the last one is isopropyl alcohol. So isopropyl alcohol, and this is the most common one used in like wounds and stuff. If you have like a bottle of alcohol that you're trying to disinfect like some surface or some wound or something, then that's isopropyl alcohol. And the IUPAC nomenclature name for that is 2-propanol. So 2-propanol. All right, so we went through alcohols, we went through carbons. Now we got to go through aldehydes and ketones. Now, one thing to know is that aldehydes and ketones, the main difference between the 2 is being on a terminal or non-terminal carbon. So first off, let's actually talk about what a carbonyl is. So a carbonyl is going to be a carbon double bonded to an oxygen. And there's 2 types of carbonyls. We are going to have our aldehydes, and these are going to be the ones on the terminal carbon, and we're also going to have ketones, and these are going to be on the non-terminal carbon. So what do aldehydes look like? Well, it's something like this. If we have, let's just say we're bonded to like a couple carbons over here, then it's an oxygen over here bonded to a hydrogen. So in our aldehydes, we are going to have that carbonyl bonded to an oxygen, but that same carbon is going to be bonded to a hydrogen. And this is what makes an aldehyde, versus if we look at a ketone would look like something like this, where our carbon is double bonded to our oxygen, the carbonyl is there, but it is bonded to 2 R groups. So R groups are just meaning like if we have another strand of carbon, like for example, I could have just written something like this, and you know that we're bonded to a methyl over here, we're bonded to an ethyl. But remember, ketones are on that non-terminal carbon, terminal meaning at the end. So aldehydes are on the terminal carbon, ketones are on the non-terminal carbon, and ketones are bonded to another carbon. So this carbon is bonded to 2 other carbons with that carbonyl going there. So what are some common names for our aldehydes? Matter of fact, what suffix do we use to indicate that we have an aldehyde? Well, for aldehyde, it'll just be Al, but for ketones, we're going to have -one. So what does this look like in, like common, let's say, molecules that we see every day? Well, one of them is formaldehyde. So formaldehyde is going to be something like this. So we have formaldehyde. Now this is the common name, but the actual IUPAC nomenclature name for formaldehyde is methanol. So as you can see, we have that metha, and then we have Al, so methanol. Another one we have to know is acetaldehyde. So this is oxygen over here. This is going to be bonded to a CH3, and this is acetaldehyde. Acetaldehyde. Well, you get the picture. I'm even bad to pronounce this stuff, and I already went through OChem 1 and 2. But the nomenclature name for this one, the IUPAC nomenclature name, is going to be ethanol, because we have 2 carbons and we have that aldehyde Al. So what about our ketones? Well, the most common one that we have to know is acetone. So now, what I'm doing right now is I'm just making it simple, and I'm just writing the CH3s, but you should be able to know that if I'm writing something like this, then you should automatically assume that this is a methyl and this is a methyl as well. But just for, just to make it easy for you guys, just wrote it to show the carbons and the hydrogens, but this is going to be acetone. So this is our common name for this molecule over here, but the proper IUPAC name is, that is not a O, that is an A. It's propan-2-one. So this is our IUPAC name, propan-2-one, because at that second carbon we have that ketone, and the common name for this is acetone. So what about our carboxylic acids? So carboxylic acids are going to be COOH, so we might have something like this, and that is a carboxylic acid. So if we have a carbonyl and an alcohol, that is what makes a carboxylic acid. Now, carboxylic acids end with oic acid, and some common ones that we'll see is formic acid. Formic acid, this is just going to be an H bonded to an OH, and this guy right here. And formic acid, the common name for, or the IUPAC name for this is methanoic acid. So that's formic acid. What about if we had something like this? And by this time, hoping you guys understand that this is a methyl. So since we have a methyl over here, this is going to be an acetic acid. Acetic acid, but the IUPAC name for this one would be ethanoic acid. And finally, our last one, we're going to have propionic acid. Man, I'm just screwing up all these pronunciations, but this is just going to be, we're going to have a ethyl bonded to this carbonyl, so we have 3 carbons in total, or we have 3 carbons, so that will be a propane. Then we have that carboxylic acid, so a propionic acid. I still got to figure that one out. So this is the common name, but the IUPAC name is going to be propanoic acid. So as you can see with all the IUPAC naming, we're ending with oic acid. So ethanoic acid, propanoic acid, methanoic acid. And in the MCAT, you really have to memorize each of these common names. So formic acid is just going to be hydrogen bonded to that carboxylic acid, and acetic acid, methyl bonded to carboxylic acid, and so forth. So we just went through our carboxylic acids. All right, so now let's talk about esters. So esters are going to have a alkox group, which is just going to be OR, and a hydroxyl. So we're going to have a alkoxy group, which is an oxygen bonded to, let's say, some sort of carbon. It's just going to be a carbon oxygen bond, and we're also going to have a carbonyl, that carbon double bond to oxygen. So and our suffix is going to be O8 for these guys. So if we had a molecule like this, this would be ethyl propanoate. So this group over here, that R group, the one connected to the oxygen on the right, is an ethyl. So we're going to start from there. And then we look on our left-hand side, we see 1, 2, 3. 3 is propane, so we have 3 carbons. But we have that suffix -oate to signify that this is an ester. So we go ethyl propanoate. So just for some practice for you guys, since esters are one of the, I guess you could say, a little bit difficult ones to name, I want you guys to find this IUPAC name for this molecule. All right, so if you guys said that this was methyl ethanoate, you'd be correct, because this R group, the oxygen connected, is a methyl. And then over here on the left hand side, we have 1, 2 carbons, so that would be ethyl, and then ethanoate, because we have to put that suffix indicating that this is an ester, and that would be the correct IUPAC naming. Now what about amides? So amides are going to be different from amines, because amines are just a nitrogen with a lone pair bonded to whatever, either a carbon or hydrogen, depending on if it's a primary, secondary, or tertiary amine. But amides, we're going to have a nitrogen plus a carbonyl group. So what would this look like? Let me scroll down a little over here. So our amides would look something like this. So if we had a nitrogen bonded over here, and we have that carbonyl group. Now, amides are going to end with amide. Pretty simple, right? So for this molecule over here, this is just going to be the same rules that we looked at with our esters. So on the right, whatever that this oxygen was connected to, like the methyl, for example, we started with that. And same thing over here, but with our nitrogen. So whatever the nitrogen is connected to, that is a methyl. So we start with, so methyl ethanamide is the name for this guy over here. Now, what if we had something like this? So I want you guys to pause this video and see if you can find the correct naming for this molecule right here. So if you guys guessed that this was an ethyl methanamide, you'd be correct, because over here the nitrogen is bonded to 2 carbons, which is an ethanol, and on our left we only have one carbon, so 1 carbon indicating methyl group, so we have methanamide. So that is how we're going to name our amides. That's what pretty much amides look like. Now our final carboxylic acid derivative is going to be known as the anhydride. So anhydrides are just going to be, if we have a carbonyl, we have 2 carbonyls, and we have a CO. So we have a carbon bonded to an oxygen as a single bond. So for anhydrides, we have 2 carbonyls plus 1 CO bond. So what would this look like? Well, a common one that we would see often is this guy over here. And this is an ethanoic anhydride. So when we're naming these anhydrides, the suffix, we replace the acid with an anhydride. So it's very similar to our carboxylic acids, where our carboxylic acids were oic acid. And that's very similar, but instead of putting acid, we do oic anhydride. So over here we can see that is an ethanoic anhydride, and another name for this, a common one, is acetic anhydride. So this is IUPAC naming, ethanoic, because we have 2 carbons on both sides of these carbonyls. We have 2 carbons, and we have that anhydride, and the common name is acetic anhydride. So that pretty much concludes our video on just, basic naming and names of all these functional groups, what they start with, what they end with, what they even look like. And knowing this is going to help us understand our reactions, understand that if we have, like the MCAT will give you something like, what if you had a propanoic anhydride? Then you should be able to memorize or actually visualize that, and it would also be helpful to write it out, because you're going to see in some of these questions, since they're multiple choice, they're going to give you a name and ask you, like, from this, what type of reaction can you create from this? So this is just the basic knowledge that we need to apply to our future videos, to our future topics. And as always, a Pomodoro a day will make you a doctor someday. I'll see you guys in the next one.